All right, so we're still in chapter 10 and we're looking at neurotransmitters. Again, this should correspond to slides 44 through 50 on our normal one. Hopefully, I've been modifying some of the PowerPoint, so hopefully I'm getting that right. So neurotransmitters. Now, neurotransmitters, as we said, these are the things that are released from the neuron that is going to transmit the signal from the presynaptic neuron, and in this case, we're kind of talking about to go into other neurons, so the presynaptic neuron to the postsynaptic neuron. That's what we had talked about in the previous video. But it also can go to other things like muscle, skeletal muscle, and whatever. But neurotransmitters are these chemicals that are used to transmit the signal from one axon to whatever it is going to be in contact with at the synapse, right? There's at least 100 neurotransmitters in the body. We're going to go over each of them, and just kidding. We're only going to go over a couple. One of the main ones is this one called acetylcholine. Acetylcholine is what stimulates skeletal muscle contraction. We looked at this in the last chapter, and still remember, acetylcholine is the most common neurotransmitter by far. And so neurotransmitters can be simple amino acids, as it says here, monoamines of amino acids, or it can be small chains of amino acids, which is what we call peptides. But they can also be really long. So, I mean, they're generally some sort of a combination of amino acids. Neurotransmitters are produced in the rough endoplasmic reticulum or in the cytoplasm. And if it's in the cytoplasm, in general, it's going to be on a ribosome because we're talking about peptides or amino acids. Remember, ribosomes are what produce proteins, and proteins are chains of amino acids. So when this action potential, which in this is just called an impulse, reaches the synaptic knob of an axon, calcium ions go into that synaptic bulb, and they are going to cause the release of neurotransmitters, right? And so it's released by exocytosis, which just means leaving the cell. Now, this is a list of the neurotransmitters, and again, we are going to look at these, especially these two, acetylcholine and norepinephrine, which again, if you remember when I told you norepinephrine or epinephrine, if you can think of adrenaline, because it is basically the same thing. Remember, I told you the idea that adrenaline, ad means above, renal, adrenaline, renal means kidneys. That means above the kidneys. Well, epi means above. Nephrin or nephron is the functional unit of the kidneys. So epinephrine and epinephrine and adrenaline are basically the same thing. Although a company has patented or trademarked adrenaline, so now we have to use epinephrine or norepinephrine, but it's the same thing. So if you can just remember to tie those together, whenever you hear norepinephrine or epinephrine, think adrenaline, and it will tell, and you should know kind of what it's going to do. But those two are the big two that I want you to know. We'll talk about some of the other ones, but right now those are the big two. Acetylcholine controls all skeletal muscle contractions, all right? And in the peripheral nervous system, this is from the central nervous system, it's not only going to control those skeletal muscle contractions at the neuromuscular junction, but it is going to have an effect on the autonomic nervous system, which we'll talk about in the next chapter. Excuse me. In norepinephrine, adrenaline will help you feel good, give this sense of well-being, and that's why low levels of adrenaline or epinephrine can cause depression. In the peripheral nervous system, we'll look at how it affects the autonomic nervous system, again, that automatic pilot, and it can either be inhibitory or excitatory. It just depends on the receptors. Now, dopamine, we're going to look at, this is really involved. You'll see later on that dopamine is going to be a big key in Parkinson's, because dopamine is going to help smooth out motor impulses. Excuse me. Serotonin and histamine. Again, not going to get into much on this right now, but serotonin is going to kind of be what is helps you sleep. It is, and histamine, on the other hand, is going to help promote alertness. And again, we'll talk about those at different times. But from this slide, acetylcholine and norepinephrine are your two big ones. Now, as this is going through, I just want to point out that what they're doing, we just looked at the first two on this last slide was acetylcholine, and then the other one were called biogenic amines. Those are classifications of neurotransmitters by structure. And basically what we're looking at is they're getting smaller as we go down. So amino acids, we'll talk a little bit about GABA as it goes through when we get into the next chapter. Not worried about it too much. We are going to talk about these two in this chapter and next chapter. Enkephalins and endorphins. A lot of people have probably heard of at least endorphins, but your body produces them in response to pain. Substance P is another one, and it is going to help you feel pain. So these two are kind of antagonistic to each other. And then finally, this last one, which is just simply a gas, is called nitrous oxide, and it is going to play a role in vasodilation or swelling. But again, these aren't as big. The neuropeptides are a classification we will talk about a little bit. Now, to look at some disorders in what happens with neurotransmitters and imbalances, I'm not going to go through all of them. I'm not going to hold you accountable for all of them, but I want to go through them. Clinical depression. Now, look, I have a feeling that especially right now, everybody's probably feeling a little bit depressed because of all that's going on. But we've all probably gone through bouts of depression. Now, when you are depressed or you're suffering from depression, if it is clinical depression, there's going to be a couple of things you're going to notice. You are going to not only feel sad, but you're going to constantly be tired. You're going to want to sleep when you aren't supposed to. And when you're supposed to be sleeping, you can't sleep. I think everybody's experienced that. Wake up in the middle of the night and your brain just won't let you fall back asleep. So if we go over here, norepinephrine and or serotonin, a deficiency in those two. So norepinephrine, we just said on the other slide, was it helps you feel a sense of euphoria type of feeling of good. It gives you alertness in a way. And then serotonin is what helps you sleep. So if I have a decreased norepinephrine, I'm going to be sad because if I have it, it makes me feel happy. And if I have a decrease in serotonin, I'm not going to be able to sleep because serotonin is what helps me sleep. So and it just kind of feeds in on each other. Then as this happens, you become more depressed, and then more depressed leads to more deficiencies, and it's a bad cycle. Now, the next one we look at is epilepsy. Epilepsy is a really strange disease. It's an odd thing. Seizures are a big thing. It is a excess of this neurotransmitter that we just kind of briefly talked about called GABA, which leads to too much norepinephrine and dopamine. So in a way, because excess dopamine would be the opposite of what we're going to look at down here in Parkinson's, which is a deficiency in dopamine. If you can think of Parkinson's, the defining feature kind of symptom of Parkinson's is irregular movements. There's a lot of what we call resting tremors. And a seizure is not a resting tremor. It is a complete spasm. So instead of intermittent, it is just one big one. And that's a kind of an excess of dopamine. Huntington's disease. This is, again, I'm not going to worry about Huntington's disease as far as what I will tell you. I'm going to star this one. Clinical depression is one I want you to know. Not going to worry too much about epilepsy right now. as far as on the test. Huntington's disease, I want you to know it's a deficient, or you don't have to know this. It's a deficiency in this GABA, and it is going to cause a loss of coordination, and it is an odd disease. But we're not going to get too far into it in here. The next two I do want you to know, insomnia and hypersomnia. I'm sure most people know of insomnia. Hypersomnia is just the opposite. Excess sleeping is hypersomnia. Inability to sleep is insomnia. Both of them are associated with serotonin. Since serotonin helps you sleep, if I have too much, I'm going to sleep too often. And if I don't have enough, I'm not going to get enough sleep. So those two, hopefully everybody knows. Mania, which is just a weird, like it says over talkativeness. Mania is just it's bad energy, kind of like you got too much. It's an excess of norepinephrine, which is norepinephrine, adrenaline. If you can think adrenaline, it is strength, but it is also agitation. If you've ever been scared really bad, after it's worn off, you're kind of shaky and stuff. Imagine that being the normal, that's what's going on. And that's what mania is. Not going to be one, but the other one I'm going to put on here is Parkinson's. No Parkinson's. Parkinson's is about tremors. There's two really stars, I guess, the face of Parkinson's. Muhammad Ali and Michael J. Fox, both. Muhammad Ali has just passed away, since they just passed away a few years ago. But they both were kind of the face of Parkinson's. So most people know what it was like, had a visual image of it. One thing I'll tell you, it's about a deficiency of dopamine. And my story that I always try to connect these two is growing up, I liked boxing. And there was Muhammad Ali was, this awesome boxer. And there was a big boxing match he had with this guy named George Foreman, long before he invented the George Foreman grill or became the spokesperson for it. He was a really amazing fighter. He was a brawler. He was Mike Tyson well before Mike Tyson was there. And anyway, Muhammad Ali was scheduled to fight him for the heavyweight title, and very few people gave Muhammad Ali a chance. And the fight was called the Rumble in the Jungle. What Muhammad Ali did, because honestly he knew he couldn't box him, but he could outthink him. So what he would do is he would lean up against the ropes and pull his hands and arms over his body and let George Foreman just swing away at him. And after several rounds, George Foreman tired out, and then Muhammad Ali knocked him out. And he called it a technique called the rope-a-dope. And he said that's why, he brought him in and he got the dope. He leaned against the rope and got the dope to come in. And which was really funny at the time. But anyway, most of you probably don't even know who I'm talking about. But I could always remember dopamine was the problem with Parkinson's because of the rope-a-dope and Muhammad Ali. Hopefully that helps. If not, not a big deal. The next one coming through, schizophrenia. It is basically hallucinations. It says inappropriate emotional response. You're just kind of all over the place. You've got an excess of dopamine and a deficiency of GABA, which again, when we're sitting here and we look at some of these, we have another one that has a deficiency of GABA called Huntington, which is a loss of coordination and behavioral changes. And then the excess dopamine, we looked at one with an excess dopamine, which was up here at epilepsy. And remember, it was seizures and loss of consciousness. So this is kind of like a combination of those, where you're just kind of all over the place. Again, that's not one I'm putting a star next to. And tardive dyskinesia, uncontrollable facial movements. I'm trying to think of who there was again, it's a deficiency in dopamine. It kind of goes back, it's almost like Parkinson's, only it is just in the facial It's like ticks. And again, there was a guy, baseball player named Jose Canseco that used to always squint his eyes real quick and make squishes in his mouth. Like he would make these weird facial expressions, and they were uncontrollable. And so this is what I believe he had as far as it goes. But again, the only ones I'm worried about on here, clinical depression. I want you to know something about these two: hypersomnia and insomnia, and Parkinson's disease are the ones I want you to know about. Now, these are things that are going to alter neurotransmitters. So again, just like the other one, there's things that I'm going to go over all of them, but not all of them. I want you to know. All right. And now, if you're getting into nursing, these are probably good slides to know where they are, because this is a lot of stuff you're going to deal with. But tryptophan. Now, not everybody's heard of it. Hopefully you have. Tryptophan is kind of jokingly the Thanksgiving drug, because it is a chemical that's found in turkey and red wine that makes you sleepy. Again, now my references are getting older and older, but and less known by people. But there was a show called Seinfeld, and there was one of the episodes where Jerry was dating a girl that had this vintage toy collection, and they were all in the boxes, and they were like G.I. Joe and stuff like that. And he was desperate to play with them, but obviously you break the box, the value goes down. So he fed her turkey and red wine, and she fell asleep, and Jerry and George broke into all the toys and played with them. But anyway, that tryptophan, that's why they call the Thanksgiving the tryptophan special, because it's going to cause you to sleep. And really, it's just that most people overeat. We're not going to worry about this one. We will talk about Valium. Valium is going to affect GABA, which is what it's going to do is it's going to make all of the receptors that bind to GABA a more effective. And so GABA is one that allows you to relax a little bit. This is going to cause you to decrease in anxiety. So that's how Valium works. Nicotine, which is, most people know it as from smoking, but it's more than just that. But by the way, do not smoke, just letting you know. But there's two ways that it works. One is straight to acetylcholine, the most common neurotransmitter in the body, of course. It's going to activate the receptors, and that's going to cause an increase in alertness. People will say, oh, it helps me calm down. It really doesn't. It actually is it's a stimulant. It increases your alertness. But what happens, the reason people think it makes them calm down is it is going to elevate the levels of dopamine, which makes you feel like you're happy. It elevates the sense of pleasure. That's the thing that kind of gets people addicted. Now, the next one I do want you to know something about is cocaine, and it is about dopamine as well. What happens with this is, see, I'm going to have a dopamine receptor here. I'm going to have a little thing of dopamine that goes in, and our body, when we want to stop using it, our body will remove the dopamine molecule, and it's called reuptake it. And so what cocaine does is it stops the process of pulling that back up. And while it doesn't produce more, it doesn't produce more like the nicotine does, it just makes what we have more effective, and it blocks reuptake. And so just like that, it's going to help us give a sense of pleasure, it describes it as euphoria. Now, understand, this is one of the ones I want you to know, but don't do coke. It is not. Don't think that this is something that sounds good, because it is. It's got much worse side effects. All right. Now the next ones I'm not going to be too worried about. Tricyclic antidepressants, norepinephrine, which again, just like cocaine, it's going to block the reuptake, and it's going to help you feel better. As it works, it's going to decrease anxiety. It's going to block the reuptake of serotonin, which is going to give you, instead of feeling all anxious, it's going to make you feel kind of relaxed. So these both go together to help be an antidepressant. Monoamine oxidase inhibitors go to norepinephrine. And so it says blocks enzymatic degradation of neurotransmitter in presynaptic cells. All it's saying is our body, as it's going through and redoing these, it'll start breaking them down and make new ones. When it blocks the breakdown of these, it helps it to be more effective in using it. And so it causes it to be an antidepressant. Selective serotonin reuptake inhibitors. Serotonin obviously is what it's going to be affecting because it's selective serotonin reuptake, and it blocks reuptake. This is an antidepressant again, and an anti-anxiety type of thing. And this is kind of a more common one that's used right now. And then we have finally the dual reuptake inhibitors. It blocks both norepinephrine and serotonin, and it just puts you in a better mood. Now, the ones I want you to know: tryptophan, I'll mark there, Valium, nicotine, cocaine, and selective serotonin reuptake inhibitors. And I'm putting that one because the name of it tells you exactly what it does. So if you miss any of the questions on that, that's a problem. But anyway, the other thing I just want to say is be very careful. All of these things, when you start trying to modify your central nervous system chemicals, it has a lot of weird side effects that you'll never even think of. It is weird to think that things that are antidepressants will increase suicidal thoughts, which is just one part of all the things that go on. So I'm not saying never to take any of these if they're prescribed to you, but I would be very careful with them. Playing around with central nervous system chemicals is not always a good deal. All right. So when we're looking at how the neurotransmitters are released, again, we've got the action potential that's going to be going along the axon to the synaptic knob. At the synaptic knob, because the calcium ions go in, these calcium ions are going to cause the release of neurotransmitters. It's done by exocytosis. Those neurotransmitters go into the thing called the synaptic cleft. And when they go across the synaptic cleft, they will bind to receptors on the other cell membrane, and that's going to change the way it works. Now we have what's called vesicle trafficking, and so some of these will be recycled. Synaptic vessels, again, becomes part of the cell membrane as it releases the neurotransmitter. Exocytosis returns the membrane to the cytoplasm to form new vesicles. It's just saying that it gets reused. So I hope this was okay. I know we're not going to get into all the different neurotransmitters. We're not going to get really in depth in this, but I do want you to know the basics. The last things we're going to talk about are specialized little neurotransmitters. And again, this is just a classification of neurotransmitters, neuropeptides. So we have acetylcholine, which is one group all on its own. Then you have something called biogenic amines, which is what epinephrine, norepinephrine is. And then you have this classification of neuropeptides. And neuropeptides in general are going to be made by the brain and spinal cord. And they can act as neurotransmitters, but they also can act as neuromodulators. Now, again, these neuromodulators I'm going to come back to, but neuropeptides, the two most common neuropeptides are enkephalins and this one down here called endorphins. Enkephalins and endorphins. They're both to help relieve pain, and they help change your sense of wellness and feeling. Again, if you've ever heard of runner's high, it is because as you're running, there's going to be a release of endorphins. Another thing, and just to make sure you all know this, I mean, and you probably do, but many of you might not. This was one of the biggest battles when I was in chiropractic, that I would have patients that would come in after an accident, whether it was a car accident or whatever, and I would tell them they need to use ice. Now, ice feels terrible when it is on, but it has really good properties. Heat is not your friend after an injury. While it might feel good short term, it is really bad long term. The heat is going to cause an influx of blood to the area, which is going to help kind of loosen things up and feel good. But that blood generally tends to pool after an accident. So when you put heat on, it'll feel good while it's on. You'll take it off. 30 minutes later, it won't feel good anymore, and the pain will come back, and probably worse. And then the first response is to put more heat on, because they don't associate the half an hour to an hour time period where it feels good until the heat comes back. They don't associate it with the fact that the heat's doing that. But what happens with ice is, if you use ice correctly, it will feel cold. And it'll probably, if it's done correctly, it'll feel hot for a little bit. And then the area will go numb. Now, look, I've learned that I got to be careful how I tell things to people. This is not using dry ice, and you're not to put the ice directly on the skin. All right. You need a little bit of barrier, but you need enough to be cold. I'm not talking about you need to put a pillow between you and the ice pack, but like a t-shirt maybe. But anyway, that numbness you feel is enkephalins that your body has released. Now, not only does the ice help release the enkephalins and these beta endorphins, it also is going to produce the fibroblasts to come in and start remodeling and have a lot of different good things that happen. The heat's not doing any of that. So anyway, the enkephalins and beta endorphins are what we refer to as neuropeptides. And so they help relieve pain. Their counterpart is something called substance P, and it's called P for pain. It is going to conduct pain impulses. It is pain. It is what makes you feel pain. And as it says here in the bottom, enkephalins and endorphins are there to inhibit the release of substance P, and that is how they relieve pain. Now, the last one on here is this thing called a neuromodulator. Modulator means to change or affect how things do. These are small substances that are released from the cell itself that will change the way the neurotransmitter acts. As it says here, which alter the neuron's response to a neurotransmitter. The neuromodulators are going to be both excitatory and inhibitory. What it's saying is neurons have a little bit of freedom to kind of try to help accentuate the signal or muffle the signal as it's going along. And it is done by the release of these things called neuromodulators. And all I want you to know about a neuromodulator is it is simply a substance that a cell can release that will alter the response, as it says here, to a neurotransmitter. All right, neurotransmitters are kind of a complicated thing, pretty basic. Well, I just want to keep it fairly simple here. Remember, acetylcholine and norepinephrine, epinephrine are the two big ones. We're really going to talk a lot about those a lot more in the next chapter. Know that, the brief little snippets of each of the disease processes that I looked over and the drugs that alter neurotransmitters that we went over. You don't have to know all of them. Just concentrate on the ones that I mentioned and talked about. All right. On that note, we will call it a day on this one.